Okay, so we'll start by describing the three main areas of the user interface of AutoCAD Electrical. At the top, you'll see the ribbon toolbar. Now, if you're familiar with recent Autodesk or even Microsoft products, you'll notice this is the style in which most of the tools are now laid out. It is possible to change it back to a classic view, that's what you prefer, but I would recommend that this is what you stick to. This is really the way things are moving forward. We can access all our different tools by clicking the tabs at the top, and within each tab we have our panels and tools to suit whatever function we may be wishing to use. Next is the project manager on the left hand side. This displays all our open projects that we're currently using. If you open up the project, we get a list of all our drawing sheets that are within the project as well. So this is where we always access all our drawings from. You notice not only is the file name displayed, but also a description of the drawing as well, which I'll explain a bit later on how we get to that. Also in the project manager, we have some parameters we can select. If I go to descriptions here, this is where I can put in the project-wide descriptions of the project. All this information can then be mapped across and displayed in our title block in the corner of our drawing. Also, we see in here our properties. Now this is where we decide how we want our project and sheets to look. For example, we have our symbol libraries. In this case, we're all pointing to the IEC libraries. If I go to the component tab, I can decide how I want my components to be numbered. For example, in the tag format here, we have these parameters. Now these are designated parameters with a prefix of a percentage sign. So for example, an F with a prefix of percentage sign means family code. So that could be a push button or a selector switch, PB, SS, CR for control relay, and so on. Next is S for sheet, and then it's N for number. At the moment we're set to number our components by the sheet number and then a sequential number throughout that sheet, 1 to however many. We can use a line reference, in which case we would select, depending on where the component was in a drawing, i.e. columns 1, 2, 3, 4, 5, etc. We would number the component like that. Also, if we're connected to a PLC, we'd automatically draw the PLC address for the name of the component. For example, it could be PB input colon 00/1, might be your input address name. Next, here we have our component tag options. These are IEC designations, the location and installation codes. These are mainly used for narrowing down and further differentiating between components and areas. They can just not only mean, for example, terminal boxes or master panels, or even in the field itself. It could also be areas within a panel or within a terminal box. Next we have wire numbers. This is done again similar to our component tags, our parameters for %S, %N, which means sheet number and sequential number, again throughout that sheet. Below we can decide how we want to display our wire number. Is it above the wire, in line with the wire, or below the wire? The next tab is cross-referencing. Again, we're going to use the sheet number and the sequential number of the component for its cross-referencing. Use that in the same drawing and also in between drawings. We can differentiate the style if we wish. And also how we want the cross-reference to be displayed. Simple text, a graphical format, or a table. In this case, we're using a table format. If we look at the setup, you can see basically how that's going to look when we place it onto the drawing. Next, we have styles. These are our defaults of how we want certain parts of the drawing to look like. For example, our arrows that take wires across different sheets. We can select a default here of what we want the arrow to look like to create our company standard or drawing set standards. These can actually be changed on insert, as can the fan in, fan out, and also the PLC styles. This is just a default of what it's going to open up to. Also, we can look at the wiring style. So at the moment it's set to the normal IEC style, IEC type, with a loop or an angled T, we can change that to solid and a dot for a T, depending on what we wish it to look. Change these back, that's how they work. And finally, the drawing format. This is what we look for in ladders. We're going to use insert some ladders when we do our control drawing later on. And this basically is the dimension of that ladder as we drop it in. So the spacing between rungs is 40 millimeters. The width between the positive and negative bus is 400 millimeters, and it's going to be a horizontal bus, horizontal ladder. Again, we can change this on insert. It's just a default. And as with the 3-phase bus wire and multi-wire spacing is set to 10 millimeters. The format referencing is if we're so choosing to use X and Y grid to number or locate our components. We can use the X zones, which is just columns, or if we were to use reference numbers, which is reference numbers along the ladder rungs themselves. And that's basically how we set up our project properties. The next part is our workspace. Now, AutoCAD Electrical always works within the model space. So when we drop in or create a new drawing, our drawing border is always placed in. Now I know this is in a white background. This is basically so it's easy to see on the video. Normally a model space is black and the layout space is white, but like I said, for AutoCAD Electrical, we always use the model space. This is basically because when we're doing our drawings, we may be using references, sheet numbers, and also references in the drawing to number our components or wires, or even our cross-referencing. So that's why we always lay the drawing border in before we start doing any drawings. Also within the workspace, we have our shortcut or right-click menus. Now these are quite clever. They will detect where we are in a drawing and give us the tool options to suit. So for example, if I hover over a wire and right-click, I bring up all the tools for wires. If I hover over a component and right click, I get all the tools for components. You'll notice that they're actually laid out in this rather nice clock face format. Now this not only makes it easy to select, but also we have a way of gesture sensitive tools as well. So basically if we look at edit component, is at the 12 o'clock position. If I to hover over a component, hold the right mouse button down and gesture upwards towards 12 o'clock, I automatically launch the insert/edit child component dialog box. And this is only just doing one click less. These are all things put in place to help us move around our drawings more quickly. I can zoom in and out of drawings using my center mouse wheel and pan across, zoom in, zoom out, pan to find areas of the drawing I want to look at. If I double click the mouse button, it zooms, extends. A few of the small items I'd like to show you within the user interface are our help menus. This text box here, if I was to type a word or phrase into it, hit enter, it calls up AutoCAD Electrical's help menu. And all the subjects that relate to the word or phrase that I typed in this case, wire. Also on the top right, we have our sign-in box to Autodesk 360. This is Autodesk's cloud-based functions and tools. The next one is the Exchange App Store. This is similar to Apple's App Store, really. Basically, there are Autodesk themselves and other third parties create little add-ons for AutoCAD. Some are free, some are chargeable, but you can access them there. You might find some little tidbits that are useful to what you're trying to achieve with your workflows. Next is the connected icon. This takes us to our subscription center or any other social media AutoCAD sites. It also lets us know of any updates, service packs, etc. that may be required on our product. In the top left, we have our quick access menu. These are our normal standard AutoCAD commands. We can modify it. There are a few commands we can take off or add on. And the very top left, we have our application menu. In here, we see our normal new open save, save as, export, what we see in most application commands. But also, we have this search commands dialog box at the top. So if there's something I can't find in the ribbon, I merely just need to type it in here, and not only will I be given an address to where that tool resides on the ribbon, so here we can see it's the wire tool is on the ribbon tab, schematics, in the insert wire / wire numbers panel, which is here. But I can also immediately launch this tool from the application menu as well. So I'm on the wires and I can just simply draw a wire in like so. Okay, so let's move on and start doing some drafting. To do this first, you need to create a new drawing. I can do that from the project manager. We have our new drawing button here. So I click on that and that brings up my dialog box. First of all, I'm asked to give it a unique file name like you would do any other DWG file. In the past, people may have used descriptions to enable people to tell what the drawing is consisting of by a file name. This is no longer necessary, as we see our description fields here, which I'll fill in a second, which are also displayed in the project manager. So we can actually just use unique numbers, for example, drawing numbers and page numbers to give our drawing our names. I'm going to keep with the current vibe and just use a sheet number to give it a file name there. The next area is the template. This is basically our drawing border. It always defaults to the last template you used, so I'm just going to keep it that and use the same one again. The location is where you want the DWG file to be saved. As a default, it always saves to the same folder as your project file, but that can obviously be changed and you can move them about any way you want to. The next area, description. I'm going to just give it a brief description here. And then next we have our other IUC designations, which I mentioned earlier on, our project code, installation code, or location code. I can actually give this a number, so the drawing itself is always going to be part of TB2. And again, at the bottom, I've got some information I can lay out. Is sheet 32, for example, any drawing numbers or section numbers I can put in there. This information here can be then mapped across and either used in our component tags or even our title blocks, again in the corner there. So once I'm happy with the information I put into the dialog box, I can click OK. It'll ask me, do I want to apply the project defaults to the drawing? Yes, I do. I want to keep a consistency throughout my project, and it creates my new drawing for me. As I've created the drawing, all the information I've got I put in has been placed into our title block there automatically as the drawing itself is created. My new drawing is displayed in the project manager. I'm just going to move that up because it's a schematic drawing. I'm just going to draw that up and place it into the schematic folder there, so it's all in the right place before I go too much further. In this case, I want to turn the grid off as well, so it helps it display the video more easily and more clearly. So I'm ready to go. I want to start drawing some circuits. I'm going to start with a three-phase circuit first of all. I'm going to draw a three-phase motor control circuit with its. So we're ready to go. I want to draw some circuits into our drawing now. I'm going to start with a three-phase power circuit, power motor circuit, and then I'm going to go on to a control circuit for that. So first of all, I need our multiple bus tool. I launch the tool from the ribbon. I'm given these options. You'll notice the spacing is 10 millimeters. That's what we had set in our project defaults. I just want to draw this in empty space along the top there. So I click OK. Our number of wires are 3. I start somewhere in the top, left click, drag all the way along, and I've got our 3 wires all in one hit. Next, I want to create a drop from there to put my motor control in, or my motor power circuits in. Go back to the multiple bus tool. This time I'm going to go from another bus, click OK. And again, this time I select the top wire, left mouse click, draw it down, and you'll see our 3 wires are placed in coming down, but also our T's and our loops are automatically put on a drawing as well. And click enter to end the command. Next, I want to start putting some components in. Now, the next tool we're going to see a lot during this demonstration is the most common thing you're going to use. It's our icon menu. And this can be found at the top left of our schematic tab. I click on the icon menu. I'm displayed with a complete list, graphical list of components and symbols that I should want to drop into my drawing. I'm going to start with a circuit breaker. So I hit the circuit breaker options. I'm breaking to a sub-menu of different types of circuit breakers: single pole, double pole, triple pole. I'm going to go to a 3-pole thermal circuit breaker. I select the option, come over and drop it in line with the first wire there. Left click to put it in place. Now, because I'm dealing in a multi-pole circuit, these components I'll want to drop themselves on the wire itself, and the wire spacing, as we've seen, is variable. So how it works is it's called parametric, and it looks for the wire gap, looks for the next wire and places the component on that wire. So the next thing the software asks me to do is which way do I want to search for the next wire, and we obviously want to go towards the right. So I hit right and it places all 3 symbols in on the 3-bus wire there. And I've got my insert and edit component dialog box. The top bit there is my component tag. This is automatically generated whenever I insert a component, defined by my parameters in the properties. So it's a QA 32, page 32, number 1 is the first one in its sequence. I'm going to put a location code in as well. That's going to be the same as what's on the drawing to keep an integrity there. And next I want to give it a description. Let's put it in capitals. Pump. So to further use this, I need to put some catalog data in as well. I want to give this not just a symbol, it's going to have some information behind it for when I come to creating reports later on. So I go to our lookup table. This database normally consists of about 1 million parts in it, but I've actually trimmed it down to make it more manageable, which you do yourself in your company. You trim it down to the actual components you're most likely to use. So not only does it maintain an easy way of inserting components, but also has less chance of inserting wrong components as well. So I'm going to put in a circuit breaker, a 45 amp one. I'm not really taking too much notice of ratings here and what it's going to achieve. I click OK, and that information is now being placed within the drawing itself. If I zoom in, you'll see a link line has been put in to make sure everyone knows that this is one component, and we've got our component tag, ratings, and a description there as well. So to continue in that vein, I'm going to put some more pieces in. I'm going to add a motor for the motor control area, a 3-phase motor. Okay, drop that in its place. We'll call that pump. This time though, because it's actually not going to be in the main panel in the terminal box, I need to give this a new location. I'm going to call this PH for pump house. Click OK. You'll notice all the wires are cut and trimmed to suit. It is possible actually, once these are in place, if you'll notice the wires are trimmed to make way for the components, but I can actually just use the scoot command and actually move these components up and down the wires and move the link components as well to make any space it may need. Let's just put them back up again, like so. And all the wires are automatically cut or healed to make way for anything I want to put in its place. Okay, I'm going to leave the starter out for me. I want to come back to that later on. First of all, I want to put some terminals on my wire, because obviously the motor is going to go outside of the panel. So as a terminal is going to be inserted more than once, I've actually got this multiple insert tool here. So if I click on that, I get a similar dialog box to the icon menu. This time I'm going to go for terminals and connectors. I'm going to go around one with a terminal number. This time I'm allowed to just draw a fence line across the wires themselves. If I click once on the left hand side, click again on the right hand side, hit enter, I'm then asked what terminals I want to place in there. So the location, will be in the TB2, the one in this drawing. And I'm going to call it X1 as a tag strip, and our first number will be 1. It's the first terminal number. The manufacturing catalogue number is default to the last ones I've used, or whatever common in the drawing, Siemens again. I click OK, and what it'll do is drop each of those symbols in there for me. I don't need to see the dialog box each time, so it puts them all in. And there's my terminals all put in one hit. Next, I'm going to put in our control circuit. And to do that, first of all, I need to put in a ladder. A ladder is what we basically work from to make it easy to place components and carry on with building our circuit. So I have the insert wire tool here. Insert ladder tool, beg your pardon. Our dialog box shows the default in our project properties. I'm just going to change that slightly to 150 because we're not going for the full size of the drawing here. I'm just going to fit as much as I can on one drawing for the use of this demonstration. But I'll keep the spacing at 40 millimeters. So I click OK. I pick a point where I want my ladder to start and just pull across to the right, and it goes. Now, as you can see, at the moment all our wires are black. They don't really mean anything. So what I want to do is change this wire layer to a control wire layer. I do that using the convert wire layer tool. I have this dialog box with all the wires in it I could care to use. I'm just going to scroll up and find a blue that's 0.5 like so. That's the cable I want to use for my control wire. I click OK, select the wire, hit enter, and it changes it to blue. Now this isn't just to make the drawing look pretty. This information can be used later on in our wire reports, but also we can put it on a drawing as well. So I use my wire color / gauge labels tool. I'll select a manual with no leader, and I'll just drop that at the top there, and you'll see our wire information is on the wire network itself. Okay, so escape to end the tool and the command. So I'm going to carry on now building our control circuit. First of all, I want a push button. Normally open momentary. I shall place that at the top. I'll give it a description. The location will be TB2. I'll go to our lookup table. Just cancel our filter out there so I can see all the push buttons I can select. And basically I want a green with one normally open in it. Click OK. Next I want a stop button. I'm going to use a normally closed mushroom head. I'll just drop that in about halfway down there. And again, go through the same process of giving a description and assign it some catalogue information. We've got the red 40 millimeters. Okay. Again, you'll notice the component tags are being generated automatically. Good. Right. Next, I want to put in my motor starter coil. So I'm going to go to motor control, motor starter, pick the symbol for coil, and I'll drop that in somewhere near the bottom of my network there. Now I shall give that a description again, and then once more we'll go to our catalog information. Break the filter. I think the AB one there should do what I'm requiring it to do. Now, if I click OK and go into our normally open, normally closed setup, you'll see we've got a maximum of 4 normally open contact counts on this relay. 3 of them are power, 1 of them is auxiliary, as we can see at the bottom here. So I click OK. Next, I'm going to move along and now put our power contacts back into our three-phase circuit. So, icon menu again, motor control, motor starter, 3-pole contacts, and I just drop them in about halfway down. And again, like the circuit breaker, I need to build it towards the right. Now this time you'll notice there's a slightly different dialog box that pops up, and that's because contacts, be it power or auxiliary, are always child components. They're child to the parent, which is the coil itself. So what I need to do now is create a link between the coil and the child contacts. I can do that simply by hitting the parent sibling button. And then I just highlight and pick the coil. All the information then passes from the coil symbol into each of my contacts regarding cross-referencing, pins, description, and also component tags. I click OK, and that gets passed to all three with a dash link line. And you can see there the cross-reference has popped up, so it's page 32, 0, and this is where we are, 32, column 0. I just want to move that down a touch, so away from the bus. And next I need to put a latching contact in for my coil. So when I hit the start button, it stays activated. So I'll go back to the icon menu again. I said we'd use this a lot. Motor control, motor starter, and I want a second normally open contact. This is basically a child normally open contact. I can drop that in there parallel to the start button. And again, I go through the process of linking them through the parent and sibling fashion. Now, just to prove a point, we noticed there was only 4 normally open contacts available on this relay. If I was to try and add in a 5th contact, I'll just put that here for the time being, and then try to link that to the coil, I get an alarm telling me that I've already reached my limit of contacts on that coil. So it's saying I can ignore the limit and carry on for the time being, or cancel. I'll have to go back and put an auxiliary contact block on front of my relay. So I'm just going to cancel for the time being. That's just to show you the real-time error checking that exists in AutoCAD Electrical. It's always monitoring what you're doing and making sure to its best it can, you're not making any mistakes. So I'm just going to tidy up this circuit now. I'm going to use my wire tool. I'm going to create a link there, so like parallel, and then I'm just going to trim the rest of the wires that I don't intend to use using the fence command again, like so, and gets rid of all the wires. You'll notice here actually my angle for my T is not really facing the right way. I can actually adjust that if I right click over it, use the toggle angle T markers, and then just tap the space bar into this new orientation I want it to be, so it looks the same as all the others. I escape the tool after that. So that's basically our circuit. Next, I want to add some wire numbers. Now, they're not always going to be unique wire numbers for this sheet. I want to bring in wires from different sheets, as is the case for our 3-phase circuit here and also our control wiring at the bottom. So to do that, I use source and destination arrows. So as this is receiving the wires, this is going to be a destination arrow wire here. So I come to the destination arrow tool, I click on the left hand side and brought up this dialog box. Now, because the source arrow isn't in the same sheet, I need to look project wide of all the source arrows that I can choose from. And I get this list. You can see here all the sources here, because a source needs to link to a destination. So I know the previous sheet is sheet 31, so I'm going to look on sheet 31 and try and find my 3-phase buses there. And here they are. Here, sheet 31. So I have 1L1. Click OK. Now I want to OK, but I also want to update the source because this is putting a component effectively in the drawer. So I need to update the cross-reference at the source as well. So as I hit that, you'll notice that the cross-reference for where it comes from is inserted. There's the wire name there, but also the wire itself has got a number on it now, 1L1, that comes in with it. So I'm just going to continue this now for the other two wires. Now I can do this by hitting the space bar, which repeats the tool, the last tool I used. For project wide, I'm going to look for sheet 31, 1L2, click OK, update source, and then again project wide, sheet 31, 1L3, OK, and update source. Now obviously I want to carry these wires off to the next page as well for future use. So I want to put some source arrows on there to take them as well away as well. So I hit the source arrow button this time. I click right near the edge of the wire. I have this dialog box. Now I have to give a source arrow a unique code. It's very similar to a component, so it's a unique code that's different to the wire number as well. What I tend to do is use the wire number as part of the code, but also the sheet number. So it's my sort of own numbering format that keeps me in check, so to speak. So I'm going to use it, sheet 32 hyphen 1L1. Click OK. Do I want to insert the destination arrows now? No, I don't. Repeat it again. Unique code, it's default to the next one in line, so I'm going to use that. OK. No. And last one, 32, 1L3, and again, no destination arrow. So let's put the power destination arrows in. I want to do the same for my control wiring now. So again, I select the destination arrow, select the top there. Now I know my control wiring actually, in this case, comes from sheet 30. So I'm going to find sheet 30 and find the positive wire number there, P0301. Click OK and update source. I'll do the same again for the negative bus. Sheet 30 and the N0301. Update source. So now I'm going to number the rest of the wires in our drawing. I'm going to start with a 3-phase because these are numbered slightly different to our control numbers. We're going to use like a 1L1 or a UVW or PQR to number our wires. So I go to the 3-phase wire number tool. I have these options, a prefix, a base and a suffix. I'm going to use a prefix of the sheet number to help me find where things are, 32. The base is going to be U to start with. I want this to actually increment each time, so I'm going to go 32U, and the suffix will be 1, but I want that to hold each time. So you can see I've got an example of what my numbers are going to look like now. 32U1, 32V1, and 32W1. I click OK. I can use a fence to insert these. I'm going to put these at the top here in line. Next, I'm going to use the UVW again, but this time I'm going to use a suffix of 2. Click OK. I'll just put these in underneath here. CAD tool the tool, and you can see then it's not very clear in the blue, but the 32U, 32V2, and 32W2 show up there nicely. Okay, so next is to number our control wires. We have the wire numbers tool here. We have a certain amount of options. I can pick the wires individually. I can do the whole project in one go, or I can just do drawing wide, which I'm going to do in this case. So it just goes through and numbers all the wires in this drawing that are left. So I zoom in one there. Because of our project properties, the wires numbers are 32, 1, 32, 2. So the sequential sheet 32, the first wire in sheet 32, 32, 1, second is 32, 2, and so on. And you can see in some instances here we can get a bit busy with our wire numbers. So what I'm going to do is actually hide the wire numbers themselves because I've already got it there as part of the label. So I come to the edit wire number tool. Underneath there I've got a little button for hide wire numbers. And I just go through there and hide any duplicates, so the drawing itself doesn't get too busy. So there is our now completed schematic drawing of our motor control and our motor power circuit. Okay, so next I'm going to draw a panel layout drawing so we can put all our components from our schematic into it. And to do that, I go through the same process before. I want to create a new drawing. I'll give it a unique file name, 28 this time, and I'll just give it a description. The location code will be TB2 and the sheet number is obviously the same, 28. So OK that. I apply the project defaults and I have my blank drawing again. So I'll turn the grid off this time. So now I want to start doing a panel layout. I go to our panel tab on the toolbar. We have an icon menu again similar, but this time it's for our panel layout footprints components. And the first thing we need to put in is an enclosure. So I choose the enclosure. I'm going to just use this normal, this is a 24 inch by 24 inch one. These are all in American. Click OK and drop them in place like so. Now, because in AutoCAD, like all AutoCADs, the scaling is always in real life as far as the components you're dropping in go. Obviously, my drawing is only an A4 size in reality. So what I need to do is actually scale my drawing to suit. I'm just going to get rid of that view on the end as well. I'm not going to use that. So I use a standard AutoCAD scale command. Let's pick the drawing frame first, scale, pick up my base point, and I'll scale it to a factor of 4. Hopefully that should fit it all in. And I'm just going to move these a bit to the top. Let's have some space. Okay, so that's my layout drawing with my enclosure in it, and now I'm just going to put in the components from my schematic. And now, because I only want to lay in the components of my schematic, I don't really want to go through the whole icon menu and have to remember what components I placed in the schematic. What I can do is, from this drop down, is select a schematic list. And what I do from here, I can choose the locations that I want to generate my list from. So because I know everything's going to be in TB2, I hit TB2 in here. And what I'll do now, I'll go through the whole project and give me a list of all the components that are stored within the location code of TB2. And here we are, the 4 of them now here. So we have our circuit breaker, our relay or contactor, I should say, motor contactor, and our start and stop push buttons. So all I need to do is highlight what I want to insert, click the insert button, and what it does then is it search through the database to find the footprint of my component, and I can then just drop that in place there at 0 degrees, and there's my component of my circuit breaker laid in. All the information has been brought through from the schematic drawing. So next I can carry on again. You'll notice as I place parts in, an X is labelled next to that component, so I know not to do it again. I can actually hide the existing ones so I don't get confused. Next I'm going to put in my relay, my contactor. I'll insert that. I'm just going to drop that in somewhere around here. Again, OK it, and then we'll go in for start, stop. And I want to go for a, see if I can insert 2 at once. Okay, that. It just goes through now and looks for the components. I'll just put the top one in there. 0 degrees. Okay, that. And it's going to look for the stop button. And I'll just drop that in underneath it, like so. And then we can see got no parts left to drop into our terminal box. So just to start tidying this up a bit, I'm going to line up my push buttons. I can right click over the component, hit the align. I want to align them vertically, so I hit a V for vertical, and I just select the components that I want to align to it. That brings it in line with the other one. Next, I want to put some nameplates on here. So I go back to our icon menu, and I select the nameplates tool. I want to go for a catalog lookup, so I want to use the ones that are associated to these push buttons. There's the AB800H. Click OK. The database searches for the footprint. Once it's found it, all I need to do now is draw a box around all the components that I want to have the nameplate on. Hit enter, and it automatically drops the nameplate onto the push button and also pulls out the relevant information that might be on there. For example, its description for its function. Okay, so now we go back to the inside of the box. I want to put some trunking in now. That's each for wires to run through. I go to the icon menu. It's actually found in the DIN rail tool. Now what I do, I have a list of all these different DIN rails or trunkings that I might want to use. I'm just going to use a small one there. I pick the rail information. I'm actually going to scale this up to 25.4 because these are often put in an imperial. So I have to be mindful of the difference between imperial and metric. So once I'm happy with that, I can just come along and draw in where I want my trunking to be. And OK that. Again, I'll go through it. Put one in below. Pick the right information, and we'll just drop that in there, like so. And our trunking goes into the drawing. Next, I actually want to put some DIN rail in, because I want to put some terminals in a second. So I go back to our DIN rail tool. I'll select the DIN rail at the top this time. Again, pick information, and I'll just drop that in there, and our DIN rail goes in like so. So next is to put in our terminals. So I go to our terminal footprint editor. A quick save the drawing. I need to select the terminal strip, so I know it's in the location TB2, and it was the only one there. The X1 terminal strip, there's 3 of them, so I go to edit. Now, I don't just want to put in the 3 terminals there, I want to put some spares in as well. So this is where I add the spares. You can't add spares in a schematic because you just put in terminals in empty space. So what I do is I highlight the terminal, I click spare. I'm going to put it in as quantity, doesn't matter. Quantity is 3 of them, 3 spares, and then just insert below, and it drops them in. Obviously, I need to assign the catalog information to them now, so I highlight my other terminal. I'm going to use this button to copy the catalog number, and then I just highlight the other 3, and then paste the catalog number, and it goes. So now, when I go to what my layout's going to look like, it's like this, and I have all 6 of my terminals in there. And I can just click the insert button now, and I drop them onto the DIN rail, click OK. We've done with that now. I'll just zoom in. Oh, excuse me. Just zoom in, and we've got our terminals on the DIN rail. You can see also that the wide numbers are placed by the terminals as well, so it makes the panel building process or any fault finding much easier. So that's our panel drawing complete. The next stage is to look at reports. We want to pull some of the information out that we've been putting into the drawing as we've been going along. So for this, I go to the Reports tab. Now, there's different sets of reports I can use. I'll show you some of the schematics first. We have the most common one is the bill of materials, and we have missing bill of materials, obviously, to find out anything we've missed out. Components, from to, wire labels. What I'm going to do is just a from to report first of all. I'm going to do it project-wide, so I process all the drawings in the project. I want to do all the locations to make sure I don't miss anything as well. And then I'm left with this list of all the wire connections. So basically this tells me the wire number, the location of component 1, the number of component 1, the pin of component 1, and also the location of component 2, the name of component 2, and the pin of component 2. Now this doesn't always, this also shows me the wire layer. So when I change the wire layer of the control earlier on, this actually is the reason why. So my panel builder now knows what wires I want them to wire all my components with. So I have this information, what do I want to do with it? I want to save it out to a file. I can do this with all the reports. And I get a selection of different file types I might want to send. So the most common one is an Excel spreadsheet. I click OK. I'm just going to put this on my desktop for now and click Save. Next it says Close No Script. I'll just close off that reports book. I go to my desktop, I hit the wireframe to Excel sheet, launch that, and you can see now, here's my Excel sheet with all my wire connections on it. Now in keeping with the reports, I can also generate some panel reports. And I get a very similar options of what I want to do with them as well. I'm going to use a bill of materials this time, but because I just want to create a bill of materials of what's in this drawing, so what's in this general assembly drawing, I click just the active drawing. I click OK. I'm going to list all the components that feature in my drawing there. And this time, instead of creating a file, I'm actually going to put this table on the drawing itself. So I use the Put on Drawing tool. I can format the table I wish. I'm going to make that writing a bit longer, a bit bigger. Or maybe change the text color to black to make it easier to read. And the label color as well, put that as black as well. Okay, so once I'm happy with my table format, I can click OK. Oh, we can see that there. It's just not going to quite fit on the drawing. Oh, yes, it does. A bit deceiving. So now we have a parts list on the drawing of all the components that are in my panel. And you'll notice now actually we have these item numbers down the side, and these refer to parts in the panel itself. So to show you what they are, I actually put balloons on the drawing. I use the balloon tool, and all I need to do is select the component, I start for the leader, and my balloons are placed on the drawing. And these obviously refer to number 50 to item 50 in our list, and that's our Siemens circuit breaker. So there you have a fairly brief, not too in-depth overview of the capabilities of AutoCAD Electrical. Any questions you may have, please feel free to ask them now.